Okay, just so you're aware, we have a quiz in 2 days. So we're going to talk about section 10.3 today, review tomorrow, and then we have a quiz. Okay? So can somebody just remind me the definition of what a chord is in our circle, Derek Pina?
Is it? Guys,
I remember.
Oh, I need to go back a bit.
Lucas.
Guys,
Okay, we have a line segment with both endpoints on the circle. Okay, so we are going to talk about chords and how those affect the measure of our arcs. Okay, so there's not pencils. I don't know. I feel like the human children have been eating pencils because they just keep disappearing.
Josh is taking it.
Okay, the first theorem we're going to talk about today is the congruent chord theorem. Do you see in this cute little picture that chord AB and chord CD are congruent? Then what that means is that the arc measurement of AB and the arc measurement of CD will also be congruent. Okay? You can go forwards and backwards with that theorem because it's an if and only if.
it says if, any, only if.
Oh my gosh. It does.
Did you write this book?
I am not that cool.
If, any, only.
We should hold them. I hate the people.
Okay. Huh. All right, could you draw this picture for me? It's the only picture we're drawing in this area.
Well, yeah, I already drew it, like the whole area before she even said that.
It's a nice circle.
It's not even the same. It's not the same though.
I just always accept that my lines are terrible.
There's the picture I would like you to draw.
This circle, I definitely freehand.
I didn't need to draw
Jeez.
I need to be able to see it.
Okay,
But then if I do this,
that's not a perfect circle.
It's like my perfect.
Because it's flat right here. Exactly. Oh,
no, because look, no.
Yeah, it's just big. Yeah, your lines look.
Oh, it's not a perfect circle, huh? Yeah, now it is. Now it is. And then there's two chords in it.
Your lines are not.
I don't know. Are we in second grade?
No, it was
Don't. Okay. I want to know the measure of arc AB. Okay? I'm going to call the measure of arc AB X. What do we know about the measure of arc BC?
30 degrees.
It's
Oh, wait, no, you can't say that. No. Wait.
it's the same as
Yeah, there
BC.
we go.
And what about arc CD?
It's the same as CB and AB.
Okay. So I know that the three unknown equal arcs
330.
plus 30 need to add up to 360. So yes, 3x is 330, which means x is, stop cawing, 110.
Because the theorem 10.6.
What?
Just give me my money. Yay!
Someone you do it. Can you just be quiet?
No, not me. Not me.
I think that's good first.
Not
That's
me.
We're gonna go to the top of the next page and look at the perpendicular chord bisector theorem. Shut your mouth, please. Okay. This is saying, if you have a diameter and you have a chord that is perpendicular to your diameter, then it is splitting the chord into two equal pieces, and these two arcs are in equal pieces.
What? That's not mine.
Huh? Okay. Can we stop talking about it, please? Oh no.
No.
Let me get a trace. Just one trace. That's all I need.
If I do it as slow as possible, it'll look super easy.
Why is it so bad?
Right.
Oh, the thing about this, like, you're right.
Yeah, right.
W circle. Don't even need a trace.
If you go as slow as you can, it'll be perfect.
Oh, I don't. That's not perfect. That looks terrible.
The thing was bent like that, so stop my life.
Have you seen my circle? This
Oh, we are.
Here is the example we're doing. I really like this example. It's a really important example, so I'm going to give you another moment to finish writing it down. Apron, next door in that like hallway behind, like that workspace behind the office, is my cart from Flex, and in that cart is my water. Could you go get it? Thank you so much. I will not continue until Avery's back with my water. Stop being annoying, please.
I thought it sounded good.
If you're outside, maybe like trying to call birds, sure, but in geometry class. Okay, we are trying to find X, which is this orange piece right here. Thank you. Does anybody have thoughts about how the heck we are going to find X? Okay. What do we know about this chunk right here?
8.
It's 8. Okay? We can make a triangle. What is the length of CD? How do you know? Because it's a radius. If CE is 10, whoops, then CD is 10. Okay, so we can say x squared plus 8 squared equals 10 squared. I know my Pythagorean triples.
I don't.
There's 6.
So it's 6.
Why am I so good at this? Guys.
Yeah.
Oh, because
Yeah.
people laugh. Guys.
Pythagorean.
Wait, what about like cross?
Yeah, I like that idea.
It's like, you know what,
I
like,
feel like you could do that.
D is, and you know
No.
what the other is.
Okay. This theorem 10.8 is saying, hey, if QS is perpendicular and it's bisecting our chord, then that makes it a diameter. So what we know is we have a perpendicular chord that's being bisected, which makes SQ a diameter. So it's pretty much like just going backwards. Okay. Wait, what?
How do you know it's a diameter?
Because it's the reverse of this right here. Okay.
Silly.
All right. Our last theorem, is about equidistant chords. In the same circle, or congruent circles, two chords are congruent if and only if they are equidistant from the center. So what this is saying is, if AB is the same length as CD, then these cute little pieces right here are the same, or vice versa.
One could say that equidistant.
So let's talk about equidistant. We need two things to show that they're equidistant. One, that those segments are equal, but what's another part of distance measurement? They better be perpendicular. In order to measure distance, it has to be a perpendicular segment. Okay? Oh, man.
Actually, need to log that.
What?
Need log you out that one.
Draw this picture. It's our last to be drawn picture.
Oh, give me some.
I want to draw another circle.
Oh, give me that. Sorry. Oh no.
That's the wrong one.
Well, I messed up on that one anyway, so. On purpose.
Every day for you.
I did this so wrong.
I read. And look at my circle. It's all almost.
Wait, like the segment CT or like the arc CT?
I'll let you figure that out.
Yeah, I figured it.
Okay. I haven't told you yet. I haven't told you. I'm waiting for you to draw it.
It looks like a baseball.
Okay. If CT is 42, what's true about CA?
That is 42.
It's 42. We know that because
Ooh, nice. Sorry.
our chords are equidistant from the center. If the measure of arc CA is 124, what's true about the measure of arc CT? Okay. What's true about the measure of arc AT?
It's
Oh, then it's 360 minus 240.
Which is?
112.
does not.
Why?
No, it's just I mean like adaptation.
Okay, did I draw it to scale? Probably not, because I just drew some things up here. Okay, but if that's their true measurement, that's what it would be.